dry, sunny and hot. Is this a sign of things to come? I'm going to be talking about how the UK's weather patterns are likely to change or not to change during the next couple of weeks and for the rest of the century. That's right, I'm going to be joined a little bit later on by Met Office climate scientist James Pope, who's going to be talking about a study in which he and other colleagues performed looking at how our weather patterns are likely to change as a result of global warming. So that's going to be a really interesting discussion. And of course, before we get onto that, I'm going to be talking about how high temperatures are expected to get during the next few days in this remarkable, albeit relatively brief, hot spell. Thank you for joining me. This is the Met Office Deep Dive, an in-depth look at the UK's weather that we do every Tuesday. If you're new to this, then why not hit subscribe on our YouTube channel, because you'll then never miss one of these when they pop up on a Tuesday. And don't forget to shout about it to your weather-loving friends. Now, as you can see on the screen behind me, we've got a classic summertime scenario for the UK with high pressure sitting very close to the country and the jet stream pushed to the north. The jet stream across the Canaries, Madeira, the Azores is diving south, and there's this area of low pressure which again is bringing some changeable weather to Iberia. This is a familiar pattern that we've seen repeat itself during the last few months, and at the moment it is bringing higher temperatures, each day warmer than the last. The reason is not because we're importing warm air from the south. There isn't much warm air to the south. In fact, parts of the Mediterranean are cooler than the UK at the moment. No, what's happening is that cloud-free skies at the moment, strong solar insolation, means that day by day the air is warming up. The sun, of course, at this time of year is as strong as it is in August. And under an area of high pressure, the air tends to sink, and that sinking air, a bit like when you pump up your bike tyres, tends to get compressed and warm up. So that's what we're seeing at the moment. We're not importing warm air from anywhere else. This is homegrown warmth, and temperatures are in fact expected to rise during Tuesday into Wednesday. That high pressure not moving far. It's always just to the east of the UK for the last day of April and the first day of May. But a subtle change then starts to take place through Thursday. As you can see, a cold front begins to drift south across Scotland and Northern Ireland. It's of course running into high pressure, so it's not going to bring much rainfall, but it is going to bring a marked temperature downturn. And by Friday, that front is introducing cooler air across many parts of the UK, although not all. I'll come on to that in a moment. But you can see those cooler colours there into the north in particular, still some warmth clinging on in the southeast. By the weekend, we've got that cooler air slowly making inroads across the whole of the UK. Temperatures for most back to average, and in fact, by Sunday, we've got a bit more of an easterly or northeasterly airflow for much of the UK, particularly towards the east. So actually temperatures below average by this stage, feeling much, much cooler on that North Sea coast, warmer towards the west. However, that's not the only story as we go into the bank holiday weekend. You might be thinking, typical, as we go into bank holiday weekend, the weather deteriorates. But I wouldn't say it deteriorates, because we've still got high pressure nearby. All that's happened is that the centre of gravity of that high has moved from just to the east of the UK, then into Thursday and Friday, it's going to be sitting more to the west. So we've got more of an Atlantic feed of air, and in fact on later Saturday and into Sunday, the isobars are pointing more towards the north. So a change of wind direction, but that high pressure then edges a bit closer in again during the weekend. So actually a lot of fine weather continuing. And the main talking point over the next few days will be the temperatures. Not for everyone, of course, but certainly for much of the UK, those temperatures are going to be remarkably high for the time of year. This is just a snapshot over the next few days of typical temperatures across the UK, typical maximum temperatures, but we can take a closer look. We can zoom in. Let's fast forward to Wednesday first of all, and if I zoom in here, and are we showing the right? There we go. I think that's showing the right one. We'll soon find out. There we go. So I can draw on the map here most likely maximum temperatures, and as you can see, Wednesday afternoon we're into the mid-20s fairly widely, 26, 27 in places, 28 is the most likely high temperature on Wednesday, somewhere between London and Bristol. But even further north into northwest England, you can see temperatures of 25, 26 or even 27 Celsius. Through the Vale of York there, 26, 25. So the warmth is fairly extensive, 22 Celsius there for Edinburgh. Southern Scotland fairly widely in the low 20s. Northern Ireland likewise. Interestingly, I looked a little earlier on at Northern Ireland's temperatures last summer, and I believe there was only one day in the whole summer in which temperatures in Northern Ireland exceeded 25 degrees. And we're getting close to that tomorrow on the last day of April. So, yeah, across much of southern Scotland, high teens, low 20s. But quite a bit cooler there for the north of Scotland. We're talking about 13 and 12, 14 for Shetland. Now, that's the last day of April. Headline maximum temperature, 28 Celsius. There's always a possibility that the temperature will be a degree or so either side of that. And that's particularly remarkable because the actual record maximum temperature for April is 29.4 Celsius. So it wouldn't take much of an error in the forecast maximum temperature of a degree and a half or so for Wednesday to be the hottest day on record in April for the UK. But that's not what we're going for as the most likely scenario at the moment. We're talking about 27, 28 Celsius across southern parts of England into East Wales. Thursday, though, we are likely to see temperatures up above that April all-time maximum, 29.4 degrees. But of course, Thursday is the 1st of May, so it wouldn't be a record. The record for May, the highest temperature ever recorded in May in the UK, is 32.8 Celsius. As you can see, temperatures a degree or so higher across the board on the first day of May. 27 Celsius showing up there for London. But if I move the pen around here, you can find a few spots that are showing 29 or 30 Celsius. Now, we're a couple of days away, and there's always going to be a little bit of uncertainty about how well the model is predicting the temperatures on Thursday, 2 days' time. Again, there's going to be an error of a degree or so. The most likely temperature that we're expecting is 29 Celsius, somewhere like London, or, again, somewhere like Bristol, into southeast Wales, for example, or actually quite widely into the east of England, northwest England. We're talking about the mid to high 20s. So most likely maximum temperature on Thursday, the 1st of May, 29 Celsius. But there's the possibility, a smaller chance, 10, 20% chance of 30 Celsius. That would be remarkable because if we saw 30 Celsius recorded on the 1st of May, it would be the earliest 30 Celsius had ever been recorded in the UK. Top of my head, might be slightly wrong on this, top of my head, I think the earliest is the 12th of May, but the 1st of May would bring it forward significant if that happened. However, like I say, the most likely is 29 Celsius, and as you can see, 28, 29 Celsius showing up there as a possible maximum temperature for Thursday. At the same time, there's quite a significant temperature contrast because if we look further north, we've got high single figures, low double figures across northern Scotland, into central Scotland, through the Cairngorms, across the Highlands, into the central belt. We're talking about mid-teens. Northern Ireland also not as warm as Wednesday. And you can see that temperature contrast by the colours because I've got the fronts on here. There we go. There's the cold front position. A little bit of uncertainty, of course, on the position of that, the north-south position, but it looks likely that there'll be this significant temperature contrast across the UK. Now, by Friday, those temperatures are lowering across the whole of the UK. Still the possibility of the mid-20s, even 27 Celsius, perhaps in the far southeast of England, but it's significantly cooler further north and west. And then by the time we get to the weekend, we're talking about back towards average, certainly by Sunday. Those temperatures, I've got the wrong data on there. There we go. Look at that. Those temperatures are significantly down across eastern parts of the UK because of this brisk northeast wind. So, interesting daytime temperatures, perhaps even more interesting overnight temperatures. Let's take a look at those before we get onto the further ahead outlook. And this is Wednesday morning, so tonight the temperatures are likely to be highly variable across the country. I'm just going to zoom in and show an example of that and then explain why. Tonight you can see by the colours, in fact, where we're likely to see some of the warmer and colder spots. Now, typical temperatures overnight will be down into the mid to high single figures in sheltered spots away from urban centres, and that's because overnight temperatures get lower from the ground upwards. So the ground is cooling first, and so the temperature actually gets lower from the ground upwards, and that cooler air slowly gets or reaches a higher slice of atmosphere gradually through the night. That's what happens. And that's why under this kind of situation where you've got high pressure, you've got sinking air, at the same time you've got cooling air at the surface, you tend to get temperature inversion. So at the lowest layers you get relatively cool conditions, 6, 7, 8 Celsius overnight as the ground cools, but you don't have to go that high up to find the warmer air which has failed to cool down in time for the overnight period. And that's why, I click on here, there are some higher parts of North Wales where temperatures will remain in the double figures, and not just higher parts of North Wales, but some lower parts of North Wales, if they are benefiting from the wind coming over the mountain or the hills and then descending and mixing the air up, so that cooler layer at the surface gets mixed up with the warmer air above the temperature inversion. And that's why somewhere like northwest Wales, not quite showing up on here, but somewhere like northwest Wales could see 14 or 15 Celsius overnight tonight. Remarkably high for an April night. Manchester there showing 15 Celsius in fact. So highly variable temperatures overnight, and even warmer night then as we go into the first morning of May. We're talking about temperatures of 16 or even 17 Celsius. Again, always difficult to find an exact location because the temperatures will be so variable. In some places it'll be 3 or 4 Celsius first thing Thursday. In other places we're talking about mid-teens. So remarkably varied temperatures. Who knows whether one of those very warm spots will be picked up by an observation, but it'll be interesting to see what happens by the 1st of May. So yeah, very warm days, and in some places, not everywhere, particularly over hills and just downwind of the hills, very warm nights as well before temperatures return back to average by the weekend. And finally, the only other piece of weather to talk about really are the showers. There are going to be a few showers around, but for the vast majority, just want to emphasise that for the vast majority, it is going to stay dry during the next few days until the end of the bank holiday weekend. Now, this is Wednesday, and you can see some shower clouds bubbling up there across central and northern Scotland. I think there's always the chance of 1 or 2 showers developing across Northern Ireland and northern Scotland on Wednesday. Into Thursday, there are more showers appearing by this stage across the UK, and there's 2 reasons for that. One is the cold front that I mentioned that's coming south, and so along that we've got this swathe of cloud and always a chance of some patchy cloud, or patchy rain, and a few showers, or even the odd very beefy shower, thunderstorm. And then further south we've got higher instability resulting from a slight change in wind direction and also the higher temperatures, and so really quite unstable air in the south by Thursday afternoon. But to compensate for that, we've got very dry air across the south, so that would suggest that there's the risk of a shower, but they'll be very isolated. However, where they do occur, it could be really quite lively with hail, thunder and lightning. Likewise, on Friday, a greater chance of showers across southern parts of the UK, some generally light showers in the northwesterly airflow across northern Scotland. And into the weekend, I think southern counties of England, particularly to the south of the M4, likely to see some extra cloud and some showers coming along. Likewise for northeastern parts of the country with the wind coming from the North Sea. By Sunday, the showers in the south have disappeared, and then most places are dry except for some of these North Sea coasts, and the fine weather basically continues into the start of next week, which is what all of this output shows. And we talked about this decider output before here in the deep dive. I think the first deep dive that we did in January, or perhaps the second, I talked to Rob Neal here at the Met Office, who decided it would be a good idea to create these decider products. And what they basically do is they summarize more than 250 computer model simulations that look 4, 5, 6 weeks into the future and assign various weather patterns to each of those simulations, and then we can work out the probability of different weather patterns or different circulation types that affect the UK and Northern Europe and the Atlantic. And that's what this is showing essentially. So if I go to, let's see, I want to go to Monday, Bank Holiday Monday, and it's showing, skip the day, edge back slightly, there we go, Bank Holiday Monday. And what this is essentially showing is the most likely top 3 weather patterns to affect the UK for Bank Holiday Monday. And what we're seeing is that trend in which higher pressure just moves to the west of the UK basically stays with us. So most likely high pressure just to the southwest of Ireland. The blue colours here indicate where we're most likely to see rain. Northern Scotland effectively, the rest of the UK dry. A northwesterly airflow or an Atlantic feed of weather, so temperatures not far from average for the time of year, certainly not as hot as the next few days. And then this is the second most likely scenario. It's got high pressure just to the southwest, a little bit further south, and again some rain for the north and northwest of Scotland, otherwise mostly dry. And this is the third scenario, so high pressure much closer to the UK, most places dry. In other words, although there is some uncertainty about exactly where that high is going to sit, it's high pressure that is most likely to be very close to the UK, maintaining settled weather, and for most this weekend, Saturday, Sunday, Monday, is going to be fine. Couple of exceptions, those showers that I mentioned in the south on Saturday, could be a thunderstorm or two as well. A few showers coming down the North Sea on Saturday and into Sunday as well, feeling rather chilly on that North Sea coast, particularly on Sunday. And more cloud, I think, this weekend because of that Atlantic feed of air. More cloud than we're seeing over the next few days and lower temperatures, back towards average. So, yeah, not as hot, not as sunny, but mostly fine. Not bad at all for a Bank Holiday Monday. Now, next week is interesting because if you were to ask me, and in fact, a few people did ask me a few days ago, how's next week looking? I'd have said it's looking rather unsettled. Low pressure returns, and the reason is because high pressure to the west drifts further west and allows low pressure to become centred close to the UK. But in the last few days, there's been a significant departure from that theme from the computer models, a significant trend towards that high pressure not drifting to the west, but staying very close to the UK throughout next week. This is Thursday the 8th of May, and it shows very similar to Bank Holiday Monday. High pressure, most likely sitting to the west or northwest of the country and maintaining largely settled weather. Always the chance that areas of low pressure will drift close to the north of Scotland to give some rain at times, a bit more of a breeze at times as well. But for the vast majority, particularly towards the south and east of the country, it's looking largely fine. Temperatures through next week, not far from average. If we get some sunshine by the day, of course, it's probably going to be a bit above average, but not as hot as this week. Overnights, light winds, clear skies. It's probably going to be a little bit below average if that happens. So temperature's not remarkable. But as far as the dry spell is concerned, with that high pressure nearby, and I know a lot of people are crying out for rain, doesn't look like away from the north of Scotland we're going to see an awful lot of it through next week because of that high pressure still in charge. And that is not going to do wonders for the rainfall totals that we're seeing across the UK this spring. Before I get into that, actually, we've got the average temperature so far this spring. This shows the average temperature as it progresses through spring. That's the black line there. That's the average 1991 to 2020 average. The red line on top is the record temperature for up to that date, and we're bang on the record at the moment, This goes out to the 28th, I believe, 28th of April, so yesterday. And we're right on the record, so wouldn't be surprised if it's the warmest May-April period on record. And as far as the rainfall is concerned, it also shows quite a significant departure from the average. There's the black line, the average, and we're languishing down there. About half the amount of rain we should have received, or what we'd normally see in the UK at this point in spring. So half the amount of rain up to this point, and that means for the full period of spring, we're on about a third of the rainfall. It's not been dry everywhere. March's rainfall distribution shows average rain across northern Scotland, but very dry in the south, whilst April's rain up to this point shows very dry in the east, but actually rather wet. That's what the blues here show. Pembrokeshire, parts of southwest England, parts of Northern Ireland. So we have had some, certainly during the last couple of weeks, we've had some systems moving into western parts to bring some wet weather at times. But yeah, certainly here in the east, it's been remarkably dry this spring, and not just spring, a couple of months before that as well. So with the weather patterns remaining very static over the next few days, with high pressure most likely to dominate, little sign of that rain that people are crying out for. And the big question is this kind of weather pattern, as we go through spring and into summer, where we've got high pressure arriving and persisting, giving us dry and very warm weather, is this likely to be more frequent in the future? Is it likely to stick around for longer in the future? Well, the man with all the answers on this is James Pope, climate scientist here at the Met Office. Welcome to the deep dive, James.
Thank you, Aidan.
Your full job title is Science Manager for the application
Ready Data Team.
Data Team. I wrote it down, and then for some reason I wrote Science Manager, Application Manager. I think I was talking to you at the same time. I can't multitask. So this is all about the application of science, right? And the first time I worked with you actually was on the 2050 weather forecast. The weather forecast, if you've not seen it, we did this 5 years ago, believe it or not. In which we projected what a summer heat wave could look like in the year 2050 based on increased levels of carbon dioxide and other emissions and land use changes in the atmosphere and so on. And the work that was involved in that was UK climate projections, wasn't it?
Yes, so we built that forecast using what we call UKCP, the UK climate projections. It's a suite of different products. We have a statistical-based, probabilistic set of projections built over many thousands of different calculations. We then also have a series of different global models that do 28 different global climate model simulations from 1900 to 2100, and then a regional model that covers sort of roughly this domain, actually the North Atlantic European domain at 12 kilometres, that does 1980 to 2080, and then we have a British Isles focused simulation at 2.2 kilometres, really high resolution, close to the weather forecasting model, again 1980 to 2080, and these are a range of different products along with some sea level analysis, and then some of the tools that we're going to talk about, such as the weather patterns.
Yeah, back in 2020 when we did that 2050 forecast, we were looking at a heat wave that lasted a remarkably long period of time. And I remember, and temperatures were getting into the 40s. And this was before a temperature in the 40s had ever been recorded in the UK. Of course, it happened 2 years later, not 30 years later. But I remember thinking at the time, this is a remarkably long period for sunny skies and heat in the UK. And we were talking about how UK summers were projected to become hotter and drier, but at the same time, winters were projected to become wetter and milder. And one thing I was thinking about, and you must have been thinking about at the time, was, is that because the weather patterns themselves are becoming hotter and drier in the summer or wetter and milder in the winter? Or are the weather patterns changing in the UK?
Yeah, and exactly, and that's where the research started. So I arrived at the Met Office in the summer of 2019, and the UK climate projections have been released in 2018 with this headline message: warmer, wetter winters, hotter, drier summers. And exactly, we want to understand, was that just a climate change signal we're seeing, or is there changes in the actual weather patterns? And because, you know, as you've been wonderfully showing here, and as you show every week's 10-day trend and videos like that, exactly where the high and low pressure sits has a real impact on the weather that different parts of the country has seen. As you highlighted just then, April, we've had a slightly damper, well, not damp, but close to average rainfall in sort of Cornwall, Devon, South Wales, but so dry over the east of England. And that sort of variation in those weather patterns is really important for a range of people looking at sort of planning in future energy, water demand, but also agriculture and a host of other sectors, even sort of transport, places like that. They're really interested in what our weather patterns do as we go out towards 2100.
Yeah, that's why it's really useful to look at these weather patterns that Rob Neal and his team developed, because they give us so much information, don't they?
Yeah, and I think it's what's quite incredible is the model we were working with to generate these weather patterns has what we call a resolution of 60 kilometres, which means that we turn the entire surface of the world into grid boxes based around latitude and longitude. And on average, in our global models, those grid boxes were 60 degrees by 60 kilometres by 60 kilometres. So they're very large, quite coarse areas. You maybe get sort of 6 or 7 boxes over the British Isles. But we can work with the weather patterns, work with this very large scale distribution of high and low pressure to take up a large area and take this quite relatively coarse information and distill it down into some surprisingly interesting regional variation. I've worked with colleagues in the Outer Hebrides, and we found differences between Stornoway and South Uist. They're about 50 miles apart, yet you can see for different weather patterns really interesting climatological signals already in our present day weather.
Yeah, because when these weather patterns were put together, as Rob explained in the deep dive that we did back in January, the weather patterns were then fed into a reanalysis model, and they could then determine, in this kind of weather pattern, what kind of rainfall do you get in here and in this part of the UK, and you get quite fine detail that other projections on lower resolution models fail to show you.
Yeah, we would never be able to determine a signal like this from a global model. It'd be very, very hard. That's where the UKCP regional, the UKCP local come in, because they can do that, but they're very expensive to run, take an awful lot of time on the supercomputer, and that's got a computational cost as we talk about it, and very large data sets. The weather patterns are much more nimble, they're smaller, and they allow us to work at this sort of still relatively fine scale, but with a much easier tool to work with. And you can see here, this is a great example that sort of eastern Scotland, reasonably dry, but really quite wet in parts of western Scotland and over the Outer Hebrides, just picking on that example.
Yeah, and this is where your paper came about, isn't it? This is the paper, by the way, Pope et al. 2021 from Climate Dynamics, Investigation of Future Climate Change over the British Isles using weather patterns. It's open access, so if you type that into Google Scholar, you'll be able to find it and look at it yourselves if you fancy it. But yeah, this is where this research came about, isn't it?
Yeah, and this was the output. About 18, 19 months or so we spent looking at this and analysing it, and really fortunate to be able to draw on some great people here at the Met Office. Obviously Rob, with his sort of wonderful knowledge of the weather patterns, as you covered earlier this year. But then colleagues across different parts of applied science, and at the end there, one of our other meteorologists able to really give us that meteorological steer. So even though we're a group of climatologists looking into the future, this is a weather-based tool, so you want that sort of experience that a meteorologist has they can bring into the tool, and that's a real advantage of doing this work here at the Met Office.
Yeah, and the way you use the tool, of course, is very similar to the way the tool's used on a daily basis for our weather forecasts, isn't it?
Yeah, and so you were just saying 250 simulations in the ensemble, run through the weather patterns, have a look at what's coming, get a percentage chance for the week ahead. And we did a very similar thing with the 28 models within UKCP, and we were able to run the model 28 times. But instead of looking at maybe a couple of weeks, a month or so into the future, we ran for 200 years, so 1900 to 2100. But what we were able to do is take each individual day for each of the 28 simulations and use exactly the same software, exactly the same piece of computer code that we're using today operationally to do decider weather forecasts, to do a climate projection from decider out into the future.
Yeah, and there's a reason you look back, isn't there? You're not just interested in looking forward, you want to test the model as well.
Exactly. To be able to look into the future, we need to be able to make sure that our model can actually do the real world currently, and that's exactly what's on this figure here. So there are two sets of boxes. These are box and whisker plots, and there's a red box which represents what we call the PPE15, which was 15 different versions of the Met Office model. We make small changes to the physics in the model and then run that simulation. We had 15 of those, and we had 13 simulations from what we call CMIP5. That's the Coupled Model into Comparison Project, a massive global climate modelling campaign. CMIP7 is just in the process of spinning up, and it supports IPCC reports and a lot of other climate science. So we've got those in purple, and the box and whiskers plot show the sort of the spread you'd see in the ensemble. We obviously got the winter months on the top and the summer months on the bottom, and you can see a distribution. So in our winter months here on the top, the lower number patterns are less common. We don't see those as frequently in the winter. And this is represented by a series of black dots, which you can hopefully make out, and they're from the Era 5 reanalysis. So the black dots are the frequency we saw actually happen over this period, so 1980 to 2010. And then the ensemble models, so the climate model simulations for the same period are then compared. And so you can sort of see that we're representing very low occurrence of these patterns in the winter. The higher numbers we're getting that we have more occurrence in the winter. So you're seeing that black dot, the vast majority of the simulation sitting inside the box, especially when it's inside the box, but within the box and whiskers plot itself, the ensemble range is capturing what's happening in the real world. That gives us confidence. And similarly, in the summer, you get the opposite trend. So we can see that we have more of the lower number patterns in the summer, and the higher number patterns are much less frequent in the winter. Much less frequent in the summer. And again, we get that trend, and our dots, our black dots of what really happened is within the ensemble. Now, these climate models weren't running exact representations of those days through the real world. So, for example, these black dots include the time when Mount Pinatubo erupted. It exerted a very large climate forcing for about 18 months. The climate model simulations didn't explicitly include that, but the black dots in the real world did. So we get those little bits of nuance that come out. But even with that, we're still able to capture the range of what we saw. And that gave us the confidence going forwards that we could look at this as a tool. We also replicated this for the spring and for the autumn, got the same sort of result. And again, when you write a paper like this, you pick out your flagship results, but we provided all of that information in what we call a supplement. So if anyone does go and read it, they can find all that as well. It's all there, and you can pore over it in detail like we did.
So there's a 30-year period in which you ran 28 simulations and saw how often various weather patterns, 30 weather patterns, occurred in those simulations, and compared with how often those weather patterns occurred in the 30-year period. And it's remarkable how close the 30-year actual occurrences of those patterns occurred with the simulations. And like you say, these kind of stormier weather patterns occur more often in the winter in reality and in your simulations. Yeah. Likewise for the more settled summer-like weather patterns, more frequently in both the simulations and the actuals. And that gives you confidence then to look to the end of the century, doesn't it?
Yes.
But you're looking at two things at the end of the century, because your analysis period was 2071 to 2099, and you're looking at two emission scenarios. Can you explain why you looked at two emission scenarios?
Yeah, so we had two sort of what you consider the end-member ensemble emission scenarios that were available at this time. So the first one is called RCP 2.6, that's Representative Concentration Pathway. It leads to a global warming by the end of the century of around 1.6, 1.7 degrees Celsius, so very close actually to the Paris Agreement target of 1.5 degrees Celsius. We then have another scenario, RCP 8.5, which is the very top end. It's about 4.5 degrees of warming by the end of the century. It's probably worth clarifying that the current emissions gap report by the UN at the end of last year suggests that based on current pledges, we're looking at around 2.6 to 3.1 degrees of warming. So RCP 8.5 is higher than what is our current expected level of warming by the end of the century. But it's still useful to see the difference that those sorts of end members of the emission scenarios into the future mean. That gives us sort of a bracket. We can sort of think about what's our likely range, what sorts of changes will we see. So it gives us that ability to explore the uncertainty.
Yeah, and the biggest uncertainty, of course, is human behaviour. How much we'll continue to emit, and whether we'll be able to bring down emissions and so on. And so it's important to look at both scenarios. And coming on to the important results here, and like the previous chart, we've got winter months on the top, summer months on the bottom, and effectively it shows this is the frequency, how the frequency of these weather patterns changes in the future, isn't it?
Yeah, so what we calculate is what we call the percentage change.
Right.
Now, because the weather patterns have different individual small percentage change frequencies in the future, one weather pattern increasing by 1% might not be a massive change, but another weather pattern increasing by 1% of frequency would be a huge change.
Okay.
And that's what's represented here. So we do the calculation of how much is the change divided by what was the original amount, and then multiply that by 100. So that's why we're able to get this, and why some of the changes are, sort of much big. They look much bigger, and we're not saying that we're going to get a 40% occurrence of this weather pattern at this time. We're saying it's increasing by a 40% chance. That's its percentage change increase.
And so for the winter, there's more of these down this end. These are the higher numbered weather patterns that are increasing, aren't there?
Yeah. So now the blue bars are the low emission scenario,
Yeah.
the RCP 2.6. The red is the high emission scenario, the RCP 8.5. So you can already see, hopefully, as you look at these bars, that while there are some where the trend is in the same direction, not all of them are, so we do have some subtle differences into the future. What definitely comes out is that the blue bars are predominantly smaller than the red bars. So in a higher global warming world, we are seeing a stronger change to our weather patterns. And you can see that if we pick on our winter weather patterns, sort of 23, 26 and 30, all a series of low pressure, westerly conditions.
So this is 23. Oh, I already had 23 picked. And this is a typical situation in which you've got high pressure near the Azores, low pressure near Iceland. This is what meteorologists call a positive North Atlantic oscillation. You typically have lower pressure near Iceland and higher pressure near the Azores. When you get even higher than normal pressure over Iceland, even lower over, did I say Iceland? I meant the Azores. Even lower over Iceland, you get this enhanced westerly airflow, and that's what this is essentially showing, isn't it?
Yeah, and you can sort of see that we see for this weather pattern 23, we've got this wetter conditions in Western Scotland, not as wet over the rest of the country. But if you cycle through sort of 26, you can see how that distribution of rainfall starts to change. So the peak is now drifted into southern Scotland, towards the Borders region, and then we're getting it also starting to see some in the Lake District, northwest of England. And then pattern 30, bit more of a leaning towards the south. That low pressure has drifted from Iceland down closer to Scotland, and this is our stormiest weather pattern. This is, if we're going to see a named storm in a winter, a good number of those named storms probably originate in this sort of setup, and particularly actually when we have that transition through those weather patterns. And
this is a common theme, isn't it, with all of the weather patterns that showed an increase in the future under both emission scenarios, westerlies.
Yeah, exactly. So we're bringing that. So that's bringing us the wetter weather, but also because of it being a westerly flow coming off the Atlantic, we're also getting that warmer weather. So we're able to actually see in the weather patterns.
This is the temperature anomaly now. So 30 is a bit less warm compared with others. Still an anomaly there of 2.0. 26, likewise the southeast. 23, much warmer than average across the UK.
So we're getting these warmer conditions, these wetter conditions, this westerly flow, and it's bringing the air this way. And this is what we and as you said, this NAO positive setup. And that's what means that what we're seeing here in the winter weather patterns is exactly what we were getting from when we looked at it statistically. The statistics were saying warmer, wetter winters. And actually, even just from the weather patterns alone, not thinking about any change in the underlying climate change effect on our temperatures, on our rainfall, we would still get warmer and wetter conditions in the winter months with these sorts of weather patterns increasing.
What you're saying is if global warming wasn't happening, But someone told us that we'd get more of these kinds of weather patterns in the future. Our weather would get warmer in the winter and wetter anyway. And that's then you're factoring in the fact that the climate is warming. Those winds coming from the Atlantic are likely to warm up as well and get wetter.
Yeah, exactly. And while none of the weather patterns disappear into the future, so we could still throw up a weather pattern that brings us strong easterly conditions, and a flow from sort of Fenno-Scandinavia, from Eastern Europe, and those sort of, maybe beast from the east style conditions. None of those patterns disappear. The way I like to think about it is that we're changing the die. So now if I roll the die in our present day weather conditions, I've got a decent chance of rolling a 1, some cold easterly conditions, or a 6, wet westerly stormy conditions. What we're saying, particularly in that high emission scenario, what we're seeing is actually we're weighting the die. We're adding a sort of a bias, so that I'm much more likely to roll a 6. I can still roll a 1, I can still get colder conditions, but just more likely. We're sort of just loading the die, pushing it in a certain direction, and that's what we're seeing. The blue bars, though, because those changes are much smaller, that actually evens out. So while we still see little increases in sort of 23, for example, pattern 30 is a little bit decreased. And so what we can actually start to see is that when you look at them on average, you get net zero change in that low emission scenario. So a bit of redistribution of where the rain and the warmer temperatures occur, as you showed the nuance of the weather patterns. That's why the 30 is so powerful. We are generally seeing no real change in the overall scenario. Our climate is much closer to what we'd expect in the present day.
And you've looked in even more detail, haven't you, with was it the Outer Hebrides that you looked at?
Yep, so in the Outer Hebrides, on average, they would see their stormiest weather patterns about 20, 22 days on average in winter. That obviously goes up and down each year. In an RCP 2.6 scenario, so the low emission scenario, there's no real change in that occurrence of those weather patterns in the future. In an RCP 8.5 world, they're looking at about 9 days of additional stormy days just in winter. Wow. So the sort of 90 days of December, January, February, almost 1 in 10 of those days switches to become a stormier weather pattern. They're not all named storms, they're not all bringing dreadful weather, but they are all likely to bring cloud, they're all likely to bring rain. And when you're up in the very north of Scotland in winter, there's not a lot of sunlight, not a lot of daylight at the best of times. So you can really imagine what that would do to you and people living on the islands. And we've been working with them so they can explore the sorts of changes they might need to make to their lives so they can continue to thrive on the islands.
Yeah, and just before we move on to summer, there are some here that show decreases, like you were saying. So I just want to show some of these. There's 16, 17, 27, 28. We just flick those on, and this shows the temperature anomalies. So 16, that's got high pressure over Denmark, more of an easterly airflow. This is one of the easterly type of weather patterns that you were saying is likely to decrease. Very similar for pattern 17. These are the temperature anomalies in January, minus 2.5, and 27, blimey, that must be one of our coldest ones, minus 4.7, proper easterly, and 28 there. So it's these really cold weather patterns that are decreasing, and you're likely to see less of them, right?
Exactly, and so even if we didn't really change the underpinning climate, that shift away from these patterns would mean that our winters we're leaning towards those warmer winter conditions. Now, on top of this, we'll have a climate change signal. So I think you possibly discussed earlier this winter when we were thinking about this setup arriving in mid-February time, because of the lack of snow this winter in sort of Eastern Europe, parts of Scandinavia, that air mass wasn't as cold as you would normally expect. So we didn't really get as deep a cold when we did get the cold conditions. We can probably expect a situation like that with the global warming impact on top of the weather pattern change as well.
Yes, double whammy effect, essentially. Now, moving on to summer, and it's actually even more stark, isn't it, the changes with some of these weather patterns?
Yeah, we really see, and we're sort of seeing the opposite happening in some of the conditions. So if we pick on 5 and 6, for example, here, and I think we're around about pattern 5 this week at the moment,
Very similar,
we?
Yeah.
And you can see that pattern 5, pattern 6 increase in the summer months in both scenarios, actually, and decrease into the future. So, in the winter.
Yeah.
And so what we're seeing is that sort of opposite. Again, you can see it with pattern 30, decrease in the summer months, an increase in the winter months. So you're really getting that that divergence in our climate, and we're seeing a sort of an enhancement of our seasonality. The winter weather patterns are warmer and wetter, the summer weather patterns are hotter and drier, and that really brings out differences between the two seasons.
I'm going to click on July now and show what these weather patterns look like in July. So weather pattern 5, above average temperatures, and we've got I think that's higher pressure near the Azores, I believe. There's no labels on there, but it's basically a rather settled weather pattern. Weather pattern 6 is very similar to what we've got at the moment. We've got higher pressure extending from the Azores, again very settled across the UK. Above average temperatures and below average rainfall. This shows below average rainfall across northwestern parts of the UK. What I found interesting, actually, we were talking about this earlier, weather pattern 19, and this is one of the ones that actually increases more than any other weather pattern in the summer. There it is, yeah. Particularly in that high emission scenario. And it's got high pressure to the west of the UK. Interesting, because this is what we're seeing next week, and it's got this north, and Sunday, in fact, this is very similar, northeasterly airflow, but it's got below average temperatures. So in a way, this isn't showing that hot, dry kind of flavour, but there's some nuances here, isn't there? Yeah.
So when we then look at the climatological difference, I've sort of been hinting on this a little bit. So as well as taking each day and assigning it to its weather pattern, I could go into the climate models and extract the temperature for that day. So what I did was I matched every single day in the 2071-2099 period for summer, for each of the weather patterns that occurs. Whenever that weather pattern occurred, what's its temperature? And I did the difference of how those temperatures had changed. And what we saw, weather pattern 19 actually has the biggest swing of temperature. So compared to the baseline period, that 1980 to 2010, it actually increases by 6 degrees in the summer. So it's 6 degrees warmer than we were sort of seeing in the present day. So that weather pattern, you know, we're sort of looking at changes here, 3 degrees below the current climatology. It's very similar to the climatology we're using in the model. What we're actually going to see is actually this weather pattern itself just becomes warmer because of the climate change signal within the model.
So these -3s end up being +3s when you compare it with that 30-year period, 1980 to 2010. And I guess part of the reason for that is the Arctic is the fastest warming part of the planet. These winds are coming from the north. And so you've just got this enhanced difference, haven't you, with the pattern itself is becoming more frequent, but at the same time, when the pattern occurs, it's much warmer than it used to be because the air upstream is much warmer than it used to be. Yeah, and this is in the high emission scenario, very end of the 21st century, we're having much less sea ice in the Arctic in the winter even. So our summer extent it's retreating. So whereas sea ice levels up here are retreating much earlier into the spring, and obviously high solar energy comes into the high latitude. So obviously northern hemisphere spring and summer, we're getting lots of energy into that part of the world, and so the ocean absorbs that heat really well. So even though we're bringing that flow down the coast of Norway, and of course less snow in winter over Norway and Finland and Sweden, and that sort of all adds into the signal to make it just warm up quicker and therefore be warmer into the summer, which is why we're getting this climatological swing. Now, I hinted at it earlier, the fact that we've got high pressure in place this week. It's going to drift a little bit through the weekend and next week, but it's essentially sticking around. And that persistence of certain weather patterns is another thing that you looked at, isn't it?
Yes, exactly. And the persistence of the weather pattern plays a really important role in our day-to-day weather. And what we can see is in the winter, pretty much all of the weather patterns decrease in persistence. So that means that they're lasting for longer. So they're lasting less longer, exactly. And so what happens is that the persistence was calculated by taking the weather pattern on a day and seeing if the weather pattern the next day was the same one or not. And if it was, it starts adding that up, and then we extract that and work out how often we had more than one day occurring. And what you're sort of seeing here is that decrease in that occurrence, which means that the weather pattern is changing more day to day than we see in the climatology, particularly in the winter months. So where we have our stormier conditions, not only are we seeing more days of patterns 26, 23, pattern 30, westerly, stormy, windy conditions, they're going through quicker. So the storms are more mobile, which potentially brings the risk and potentially be more impactful because they just have that they're moving quicker, they can deepen quicker, and the associated impacts can come from that. Conversely, in the summer, patterns like 5 and 6, those high pressure patterns you just had up, they persist for longer. So their persistence actually increases, they last longer, and that allows us to end up in these sorts of more blocked regimes where the air gets stuck, it gets trapped, we end up building up the heat within it, as you were sort of highlighting about with the high pressure, that air can sink, it can get warmer, but also associated risks in that, of course, sort of air quality and things, depending on where the airflow is coming from. So you might have increase in air pollution, might increase in pollen and things like that. It all gets stuck because there's no real change in that air mass either, because it gets stuck because the persistence is increased.
And you get higher temperatures because in the UK, when you get high pressure lasting, day by day temperatures rise, which was what we're seeing this week. And so you've got the higher temperatures because you've got the more frequent high pressure, you've got the more persistent high pressure, and as you said, the high pressure patterns are warming themselves as well.
Yeah.
Triple whammy.
Exactly, yeah. And, that sort of builds a nice... And when you mentioned the future weather forecast, well, one of the ways that we assess to design that, to find that example, was we used the weather patterns as a base template, and we found periods where we had that persistent weather patterns 5 and 6 to exactly as it happened in that forecast, build up that heat, get stuck, and just day by day, finishing with the 42, 43 degree Celsius heat wave we have at the peak of the video.
Yeah, really interesting. So just to summarise, 30 weather patterns that we talk about often in the deep dive. You've been looking at how they're likely to change in the future. They all still happen. They all still happen at the end of the century in a high emission scenario and in a less high emission scenario. They're still happening. But in the winter, the wetter, milder westerlies happen more often. The easterlies, southerlies, northerlies happen less often. In the summer, high pressure happens more frequently. And when it happens, it's more likely to stick around. And on top of all of that, the winter weather patterns, as you were saying, are on average getting wetter and milder. Every single one of them is getting, even the easterlies, they're getting milder, they're getting wetter. And the summer weather patterns are getting hotter and drier, every single one of them. Even the especially the northerlies, are getting hotter in the summer. So really interesting research that you've done into that, and really important, when we're looking further ahead and planning for the future. So thank you very much, James Pope. I hope you enjoyed that and found it really interesting, like I did. But that's all we've got time for this week. Don't forget to hit subscribe, send us a comment, send us a question, and we'll try our best to answer. Thank you. Bye-bye.